Hello students, let's continue the session on playing with the numbers. Today we'll be completing exercise 3.6 as well as 3.7 so that all the questions of exercise related to playing with the numbers will be complete. Let's start with question number 2. What is the highest common factor of two consecutive numbers? The highest common factor of two consecutive numbers is always 1. The reason I'll give with an example. If I consider some number 5, the next number will be 6. The highest common factor of these numbers is 1. This is holds true for all consecutive numbers. Whenever pair of consecutive numbers are considered, we get the highest common factor as 1. What is the highest common factor of two even numbers? Whenever two even numbers are there, their highest common factor is 2. So for example, if I consider 10 and 12, the highest common factor will be 2. The reason is, if I do this, 10 and 12 divide 10, we get 5. Divide 12, we get 6 times, 2 3 times. So 10 is the product of 2 and 5. 12 is the product of 3 and 2 square. So with these two, I can find out the highest common factor. We need to find the common factor with the lowest power. The lowest power is 1. So the highest common factor is 2. C. Highest common factor of any two consecutive odd numbers will be 1. If I consider 5, the next consecutive number is 7. The highest common factor of 5 and 7 is 1. This holds true for any two consecutive odd numbers. Question number 3. Highest common factor of two co-prime numbers 4 and 15 was found as follows by factorization. 4 is 2 into 2, 15 is 3 into 5. Since there is no common prime factor, so the highest common factor of 4 and 15 is 0. Is this answer correct? No, it's not correct. If not, what is the correct highest common factor? The highest common factor is 1. The reason is, whenever the highest common factor is considered, 4 we have to consider 1 into 2 square, and 15 is 1 into 3 into 5. The common factor here is 1. So the highest is also 1. Now we shall begin with exercise 3.7. There are many questions in exercise 3.7. Let's see one by one. The first question is, Renu purchases 2 bags of fertilizer of weights 75 kg and 69 kg. Find the maximum value of weight which can measure the weight of the fertilizer exact number of times. So it's a question related to the highest common factor. For finding maximum weight, we have to find highest common factor of 75 and 69. To do that, let me write the factors of 75 by factorization. So 3 into 5 into 5, because 75 divided by 3 is 25 times 5 is 25. and the factors of 69 is 69 divided by 3 23 times, so it is 3 multiplied to 23. 23 is the prime number, so here highest common factor is the number which is common with the lowest power. It is 3 raised to the power 1. Therefore the required weight is 3 kg. Let's see the second question. 3 boys step off together from the same spot. Their steps measure 63 cm, 70 cm and 77 cm respectively. What is the minimum distance each should cover so that they can cover the distance in complete steps? Here, this is a question related to the least common multiple. For finding maximum distance, we have to find LCM of 63, 70 and 77. We have learned to calculate the least common multiple using prime factorization. Let's follow that. This number is divisible by 3. This number is divisible by 2. So let me divide by 2. It's 35 times. 77 is written as it is. 63 is written as it is. Now I'll divide by 3. 321 times is 63. Here the numbers are not divisible by a same number, so let me consider one more times 3. So 7 times is 21, so 35 written as such. Then it is divisible by 5. 5 7s are, then it is divisible by 7. 7 1s are, 7 1s are, 7 11s are, then it is divisible by 11. Here the least common multiple is 2 multiplied to 3 square multiplied to 5 multiplied to 7 multiplied to 11. This is same as 2 into 9, which is 18 multiplied to 5. 18 multiplied to 5 multiplied to 77. On complete multiplication, we will be getting this as 6930. So 6930 centimeter is the minimum distance each one should cover. Here I have written as maximum. It has to be minimum distance. So the minimum distance to be covered is 6930 centimeter. Question 3. The length, breadth and the height of a room are 825 centimeter, 675 centimeter and 450 centimeter respectively. Find the longest tape which can measure the 3 dimensions of the room exactly. So we need to find out the highest common factor of 825, 675 and 450. First let me find the factors of 825. So I will do prime factorization. I'll express as a product of prime. So let me divide this by 3. 3 2s are 6, 2 remains, 7s are 5s are. Now this number is not divisible by 3. Let me divide by 5. 5 5s are 25. 5 5s are 25 again, so 5 11 times. 11 is a prime number, so this is 3 multiplied to 5 square multiplied to 11. Now let me find the prime factorization of 675. So let me do it here. 675, this number 675, is it divisible by 3? 7 plus 5 is 12, 12 plus 6 is 18, so it's divisible by 3. 3 2s are 6, 3 2s are 6, 3 5s are. Now once again it is divisible by 3. 3 7s are 21, 5s are, once again it's divisible by 3. 3 2 5, so 5 times, so we have 3 cube into 5 square. Similar way we will find the prime factorization of 450. So 450 has to be divided. Let me divide it by 2. So 2 2s are 2 2s are 2 5s are. Then this part continues. It is divisible by 3 75 times, 3 25 times, 5 5 times, so we have 2 multiplied to 3 square multiplied to 5 square. Therefore we can find the highest common factor. It is common factor which are having the lowest power. The lowest power of the common factor, first will let us identify. I'll highlight that. 3 is present in all the 3. 5 is also present in all the 3. So I have to find out the least power of 3. The least power is just 1. So 3 into 5 is having the power, minimum power is 2. So 3 into 5 square is 75 centimeter. This should be the longest tape. Therefore the longest tape required is 75 centimeter. Let's start question number 4. Determine the smallest 3-digit number which is exactly divisible by 6, 8 and 12. So in this case we will be finding the least common multiple of 6, 8 and 12. To find the least common multiple we follow prime factorization. So let me divide by the smallest prime number which divides the numbers here. So it is divisible by 6 is divisible by 2 3 times. 2 4 times is 8, 6 times is 12. So 3 written as it is, 2 times, 3 times. So 2 1 time, 3 and 3 is written as it is, 3 1 time. Therefore the least common multiple is 2 cube multiplied to 3, nothing but 24. The smallest 3-digit number is 100. So to find the number we have to divide 100 by 24. So when 100 is divided by 24, it is 4 times 96. 4 will be the remainder. Therefore the required number is 100 plus 24 minus the remainder, so it is 120. So 120 will be the smallest 3-digit number which is exactly divisible by all these. Let us solve question number 5. Determine the greatest 3-digit number which is exactly divisible by 8, 10 and 12. In the previous question we have found the smallest 3-digit number. Similar way we will find the largest 3-digit number. For that, first let us find out the LCM of 8, 10 and 12. Then we would consider the largest 3-digit number. The largest 3-digit number is 999. So we'll divide 999 by the LCM. So let me first find out the LCM. The LCM of 8, 10 and 12 has to be found. So 2 divides 8 4 times, 5 times and 6 times. Once again divide by 2. Once again divide by 2. 3 one time. So 5 one time. So the LCM is 2 cube multiplied to 3 multiplied to 5. We'll be getting it as 120. So 120 divides 999. If you take 8 times 960, so 39 will remain. So therefore the required number is 999 minus 39, 960. So the largest number, which is a 3-digit number divisible by all these 8, 10 and 12 will be 960. Question number 6. Traffic lights at 3 different roads crossings change after every 48 seconds, 72 seconds and 108 seconds respectively. If they change simultaneously at 7 a.m., at what time will they change simultaneously again? In this case also we'll be finding the LCM of 48, 72 and 108. To find the LCM, let's follow this prime factorization. 48, 72, 108, all the three I'll divide by 2 now. So all are even, so it's divisible 24, 36 and 54. Now let me divide once again by 2, 12 times, 18 times, 27 times. Now 2 6 times, 2 9 times, 27 is written as it is. 2 3 times, 9 and 27 written as it is. 3 1 time, 3 3s are 3 9s are 3 1s are 3 3 3s are once again divisible by 3. Now look at 2 is repeated 4 times, 3 is repeated 3 times, so it is 2 to the power 4, which is 16, multiplied to 2 cube, which is 27. The product is 432. So 432 seconds. Therefore, after 432 seconds, the light change simultaneously. What is 432 seconds? 432 seconds is same as 7 minutes 12 seconds, because 7 multiplied to 60 is 420, 420 added to 12. Therefore, the time will be 7 hours, 7 minutes and 12 seconds. This will be the time. 7 a.m. plus 7 minutes 12 seconds. Let us solve the 7th question. 3 tankers contain 403 liters, 434 liters and 465 liters of diesel respectively. Find the maximum capacity of the container that can measure the diesel of 3 containers exact number of times. In this question, we will be finding the highest common factor of 403, 434 and 465. So we need to express each of these numbers in terms of a prime factorization. We can write this as a prime product. 403, the number is not divisible by 3, it's not divisible by 7, 7 4s are 28, 12 will remain, 7 5s are 35, 5 5 3, no, it's not divisible by 7, it's divisible by 13, 13 3s are 39, 1s are 13, correct. So 31 one time, so it's written as 13 multiplied to 31. 434 is divisible by 2, 2 2s are 2 one time, 2 7 time. This number is not divisible by 3, it's divisible by 7, 7 3s are 7 1s are, so 31 one time. So this is 2 multiplied to 7 multiplied to 31. Next we have 465. 465 is divisible by 3, 3 one time, 3 5s are 15, 3 5s are 15 again. So 5 3s are 5 1s are, so 31 one time. So it's 3 multiplied to 5 multiplied to 31. So look at the common here. Common is 31. Therefore, highest common factor is 31, which means 31 liters of container is required to measure the quantity in each case. Question number 8. Find the least number which, when divided by 6, 15 and 18, leaves the remainder 5 in each case. First we will find out the least common multiple, that's LCM. So we'll find the LCM of 6, 15 and 18. Then they have given that 5 will be the remainder. We shall add 5 to the LCM. We will get the required answer. So 6, 15, 18 is divisible by 2 to 3 times. 15 is written as it is, 9. So now 3 divides 1 time, 5 times, 3 times. Once again 3 should be considered, 5 should be considered. Therefore the LCM is 2 multiplied to 3 square multiplied to 5, nothing but 90. Therefore the required number is 90 plus 5, 95. Question number 9. Find the smallest 4-digit number which is divisible by all these: 18, 24 and 32. Let me first find out the LCM of 18, 24 and 32. Then we'll take the smallest 4-digit number, then we'll divide by the LCM, then we'll do subtraction of remainder from the divisor and we'll add it to the least number, 4-digit number, then we'll get the required number. So 18, 24, 32, we will divide it. 2 9s are, 2 12s are, 2 16s are. Once again let me consider 2, 6 times, 8 times, once again 2, 3 times, 4 times, once again 2, 2 2s are, once again 2, 9 3 1. Now divide by 3, 3 3s are, 3 1s are, 1s are, 3 1s are, 1s are, 1s are. Okay. What is LCM? 2 is repeated 5 times and 3 is repeated 2 times. 32 into 9 is 288. Therefore, the smallest number 1000 must be divided now by 288. 3 times is 864. 136 will be the remainder. Thus, required number will be 1000 is added to 288 minus 136, whatever the remainder is. 1152 will be the required number. Question 10. Find the LCM of the following numbers 9 and 4. To find the LCM, I'll just follow this method. 9, 4, I'll divide. So 2 times, and 2 1 time, 3 3 times, 3 1 time. Alright. So LCM of 9, 4 will be 2 square into 3 square. So 4 9s are 36. You just observe here the LCM is 9 into 4, 36. It is the product of the number. Actually, for this case, we have the highest common factor as 1. That is the reason why we get the least common multiple as a product of these numbers. If you want to find 12 and 5 LCM, 2 6 times, 2 3 times, 3 1 time, 5 1 time. So 2 square into 3 into 5. So 4 into 3 into 5, nothing but 60. 12 5s are 60. So LCM is the product of the numbers. If you want to find for 5 and 6, 2 3 times, so 3 1 time, 5 1 time, LCM is 30. It is same as the product of the number here. 15 4, 2 2s are 2 1 time, 3 5s are 5 1 time. So the LCM in this case is 60, and it is same as the product of the numbers. This is the last question of the exercise and last question of this chapter. Find the least common multiple in which one of the number is the factor of the other. 5 and 20. For 5 and 20, if you find LCM, it has to be divided by 2. So 2 5 times, 5 1 time. So the LCM is 2 square into 5, nothing but 20. What do you observe? Here, one of the number is the factor of the other. So other number will become the least common multiple. With this, I can identify the least common multiple is 18, in this case 48, in this case 45. You can check it. With this, we have completed playing with the numbers. In the next session, we shall discuss the combination of the first 3 chapters, and it is discussed as number system in NCERT exemplar. We shall take up the questions of NCERT exemplar. It will be a revision for the three chapters. Thank you.